Okay. All right. And again, thank you so much for being here for Wildlife Wednesday. Right. So some virtual engagement guidelines for tonight. To get the best experience possible, I encourage everyone to keep your video off and also to keep your mute on. And what that'll do is really help keep the bandwidth the best possible and to minimize any background distractions for our presenter and for those who are attending. And I encourage you to view your screen in full screen mode. And what that'll do is make sure that no photos are getting chopped off, that you can really see everything that's being presented. And if you have any questions at any point throughout the presentation tonight, please throw them into the chat whenever it comes across your mind, and we'll address everything in the last 10 to 15 minutes of the presentation time. That'll be specifically for the Q&A session. And most importantly, just sit back, enjoy, and learn something new. Ask questions if you have anything, and be curious. I want to say thank you to our members tonight with the Alaska Wildlife Alliance. Because of them, we could not have these presentations free for the public. So really is valuable to us to have you all here. And if you are in attendance and are a member, thank you so much. So AWA has 3 pillars of work that we really focus on. We have some citizen science. For example, we help monitor the critically endangered Cook Inlet belugas along Cook Inlet, and we co-host the sites of the Kenai and Kasilof River monitoring sites. And that season starts on March 15th and goes through May 15th this year. So coming up. And we also do some education. If you are in Juneau, maybe you've seen our posters on the electric bus system, and maybe you've seen us at some summer events as we've been tabling, and we do these Wildlife Wednesdays, a whole host of activities where we get out and connect with the public. And then we also have quite a bit of advocacy. In the fall, we filed a lawsuit to help better protect the Beaufort Sea polar bears from potential harassment. And we also we had a proposal to the Board of Game that we should be hearing back from soon, the results of that. It was proposal 199, and we're asking for 50-yard trap setbacks on multi-use trails in the Matsu Valley in Alaska. So we will see pretty soon what the results of that were, but if you commented in support of that, we are very grateful that you were able to support us and through proposal 199, so thank you. If you would like to see any other news that we've been a part of, there's an article discussing our trap setback proposal a little bit more. There's also our vice president has been featured in some articles recently, and in the news we are also involved in a group that is working to really urge the feds to better protect beluga whales, those Cook Inlet beluga whales. So you can read more on our website on all of that. And some upcoming events. We have these Wildlife Wednesdays through April, and they are recorded and posted to our YouTube, our website, and our Facebook page. And we also have the spring monitoring season for those beluga whales, as I mentioned. And if you're interested, you can sign up at akbmp.org. And you can also attend the training session on March 30th, at the end of the month, and then you'll be good to go to know how to monitor those whales. And the Kachemak Bay Marine Mammal Forum is coming to Homer in April, and we're really excited. This is a new event. We are going to be sharing information with the public, especially water taxi services and recreators in the area who have been requesting such a forum. And we're also just hoping to make it family friendly and just celebrate marine mammals down in the Homer area. So check out our website to see more of that, and I'll throw a specific link in the bio. But more details are being fleshed out on that. So stay tuned. And as I mentioned, we have Wildlife Wednesdays recorded, and we had a climate adaptation workshop that wrapped up I believe it was 2 weeks ago, and the recordings are on our YouTube if you want to catch all of that information. And then this is the last month that you can shop at Blue Market, and 1% of the proceeds will go to AWA. And Blue Market is a zero waste, cute little market in Anchorage. And if you're in the area, you should check them out because they're pretty incredible. And lastly, we have wildlife calendars still for sale, and it's still early in the year. You can still support by purchasing those and helping support local artists as well. We want to say thank you so much for being here. And if you want to support wildlife, you can become a member with AWA for as little as $35 a year. It's well worth it, and everything goes directly to our programming. And if you would like to support in other ways, you can visit some of those resources that are featured below on the screen. All right, I'm going to hand it off to Veronica, but thank you so much. And I am looking forward to hearing your presentation, Veronica.
Awesome. Thank you so much. Let me share my screen. Awesome. All right. Hi, everybody. Thanks, Kelsey, for that lovely intro. I'm really excited to be here tonight chatting with everybody. What I'm going to present to you about marine debris in the Bering Sea is actually my graduate research. This is my truncated version of my defense dissertation. So it's something that I've been working on for a really long time. And basically my work has been to combine historical records, toxicology, and local knowledge to assess impacts and identify solutions about marine debris in the Bering Sea. So first, before I start anything, I want to give a land acknowledgement. I'm coming to you from Anchorage, which is Dena'ina territory, but the work I've done throughout, the past decade has been in the Aleutian Islands and the Pribilof Islands, which is home to the Unungan people. Just to give you a quick overview of what to expect in the next 40 minutes, I'll start with a short introduction. In chapter 1, I'm going to review the history of marine debris research in the Bering Sea region, and then talk about contaminants related to marine debris in the Bering Sea. And finally, how marine debris impacts communities in the Bering Sea region. And then we'll wrap it all up. And actually, I'll give the shout out now before I forget to do it. Next week's presentation from Kim is sort of this extension of like when we get to conclusions and think about prevention measures. Kim's work is really important in that field. And so I'll just give the plug to see Kim's presentation next week. So the overarching question that I posed during my many years of research was, how does marine debris impact the Bering Sea? And anybody familiar with the marine debris issue? This is a really big question to ask. Marine debris is a super complex global issue and impacts the environment on multiple scales, from microplastics to macroplastics, I mean, even nanoplastics, right? And impacts all parts of the environment and impacts humans as well. So asking this question means that finding the answers requires looking at it from multiple perspectives. And while I can't give you all of the answers within this presentation and within the scope of my research, I tried to answer a few of them. And I did that using this method of transdisciplinary research, which basically expands beyond single discipline-based knowledge to span multiple knowledge systems, bridging academic and practitioner perspectives, meaning that I sort of used concepts from ecology, concepts from social science, education, environmental justice, and sort of brought them all together to kind of build this big picture of how marine debris impacts the Bering Sea region. So first, we're going to do sort of a really brief intro on the history of plastic. And I'm focusing on plastic because when we're talking about marine debris, most marine debris is made of plastic. And that's because that stuff is used very often by humans, has a high probability of becoming waste, and stays in the ocean for a really long time. So plastic was actually created to replace ivory, because billiards became a really popular sport at, late 1800s, early 1900s, and they needed a material besides ivory to create billiard balls. That's where we get Bakelite. It's the first fully synthetic plastic, and it was created in 1907. But we don't really see a sharp increase in the production of plastics until about the 1950s. And then from there, production increases exponentially. And you can see that in this graph here in terms of the millions of tons that have been produced over time. And just for example, production of plastic grew 26% between 2010 and 2016, from 334 million tons to 422 million tons. Now, why is this a problem? It's a problem because plastic waste is difficult to manage. There are lots of things in our lives that are made of plastics that we don't necessarily throw away right away, but on the opposite end, there are also lots of things that we use once that are made of plastic and then we throw them away. I'll give you the example of straws or plastic bottles or the lids on coffee cups. We just use them once and throw them away. The other thing about plastic is that it does not biodegrade. So once it ends up in the environment, it might break down or erode, but it doesn't biodegrade or return to the environment as something that is natural again. And poorly managed plastic runs the risk of becoming marine debris. And the problem is that once it gets out into the middle of the ocean, it's a transboundary issue, meaning that no one really needs to take responsibility for it because it isn't within some country's boundaries. So a couple of plastics by the numbers. 75% of plastic cumulatively, oh man, that is a hard word for me, cumulatively produced since 1950 is waste. A third of plastic waste is mismanaged and at the risk of polluting the environment. And over 150 million metric tons of plastic are estimated to be in the ocean. There are lots of other numbers related to marine debris in the ocean, but these are some of the big ones just to give you an idea of how massive this problem is when it comes to waste in the ocean. And the thing about marine debris is that it results in numerous adverse impacts. When it comes to wildlife, wildlife can get entangled in marine debris, wildlife can ingest plastics. And in this picture, what you see, this is actually a picture from St. Paul Island, and these are red-faced cormorants in their nest, and they've incorporated the plastics into their nest. So there are lots of things that happen when plastics and marine debris gets into the environment, and various impacts from this form of pollution. So returning to the Bering Sea and this question of how does marine debris impact the Bering Sea? The first question that I asked in my research was, what do we know about marine debris research, monitoring, and cleanup activities in the Bering Sea? And what do we still need to find out? Because knowing what's been done helps shape what still needs to be done. And that was a really important part of this work for me, because we didn't want to, repeat things that we already knew. We wanted to be able to expand our knowledge and really get a deeper understanding of these impacts in the Bering Sea region. So that leads us to the first chapter, a review of marine debris impacts in Bering Sea social ecological systems. Just to give you an idea of which part of the Bering Sea that we're concentrating on, basically all of it. So everything in this big circle, this big square, is sort of what we were thinking about when we were putting together this particular research chapter. The objectives of this portion were to synthesize research, monitoring, and cleanup activities to better understand the sources, prevalence, and impacts of marine debris in the Bering Sea. So we could identify what the knowledge gaps were when it came to marine debris research and recommend future research priorities. How did we do this? We did an integrative review, which meant that I looked at all the literature online that was available related to research on marine debris in the Bering Sea, and presented the central concepts from all the literature that was reviewed to identify these knowledge gaps and outline the research needed to advance the field of marine debris research in the Bering Sea. So this took a lot of internet searches on Web of Science and Scopus and Google Scholar to find all of the things that have been published regarding this type of work in this region. And then I needed to sort the types of debris that were being done. So first I sorted by the category marine debris that was focused on in the research. One was macro debris, so the big pieces of marine debris, like those that end up on the shoreline and things like that. The next was micro debris, so the smaller pieces of plastic. You think about this when we're thinking about things that get mixed up with the sand or animals ingesting these small pieces of plastic. And then specifically like the contaminants that are related to marine debris, like plastic additives, or plastic is also able to absorb contaminants like persistent organic pollutants. And so research centering on that. Oops, sorry, my computer is yelling at me for a second. Let me do this. Okay, great. And then from there, I further categorized the research. So was it macro debris and wildlife? Was it macro debris and environment? Or was it macro debris and people? And I did the same for micro debris and chemicals. And from each paper, we extracted important pieces of information, including the prevalence of marine debris that was measured, the sources of the marine debris, and the impacts related to the marine debris that was being studied. So what are our results? Basically, what I'm going to present to you over the next few minutes is a timeline of the research that's been done in the Bering Sea region and the categories that sort of pop up within these certain timeframes. So what you're going to see across the top is a smaller version of what you see here to let you know what part of the timeline we're in. So first, the research that I found showed that the first observations of anything related to marine debris were northern fur seal entanglements in the Pribilof Islands in the 1930s. And that was kind of an interesting find for me because I've been working for the Aleut Community of St. Paul Island tribal government since 2017. And one of our big, drivers of the research we do is around northern fur seals. They're a really important part of the island and the ecosystem. And so they're very integrated into my world. But I hadn't realized until I started doing this background research how important they were in driving marine debris research in this region as well. But you don't see the research really start until the 1960s, but it does center on northern fur seals and marine mammals and entanglements. And since starting in like the late 60s, they started monitoring northern fur seal entanglements on St. Paul Island. And you can see in this graph, the percentage of subadult male northern fur seals that are entangled in debris by, and they did this in two different ways. At a certain point, seals were commercially harvested in the Pribilof Islands. And so they would do roundups of seals during the commercial harvest and count the entangled seals. And so that's kind of the percentage that you see up until the mid 80s. And then when the commercial harvest ended, they would do research roundups and then track entangled seals at that point as well. And so, in the 70s, you see this high spike of percentage of northern fur seals entangled, and then it sort of drops down. But, the thing that's happening at the same time of these drops is that the northern fur seal populations are also declining. So just because the percentage of entangled seals is declining, it doesn't mean that it's not still a problem and it's not dropping off to zero. And the other thing that's really important to know is that this sort of higher rate of entanglement in the early part of this research is coinciding with an increase in trawl fisheries in the Bering Sea region. And many of the seals that they find entangled are actually entangled in trawl net webbing. And so that becomes sort of this, there's a correlation a bit with increased in fishing activity and seals being entangled. Some of the attributes to the decrease in entanglements are thought to be related to better education of the commercial fisheries in terms of like taking better care of their gear so that there is less gears discarded or lost at sea. And so that could have played a role in the decrease in entanglements also. I will say that, despite a decrease in that percentage, we still see entangled seals today on St. Paul Island. And these are pictures of some of our disentanglement teams. And on the right is actually our current team, my colleagues at Tribe and Mike Williams from NOAA, who, they do a really good job each summer monitoring the northern fur seal populations and looking for entangled seals. And every time that they find one, they make an attempt to disentangle those seals. So this is still a big part of what we do on St. Paul. So the other thing that popped up in the literature in terms of research in the 60s was looking at seabirds in the Aleutian Islands and examining their gut contents. And what they were finding even back in the 60s was that certain seabirds were ingesting pieces of plastic, What you see here is a graph from a paper that compares seabird gut contents in the 60s and 70s to seabird gut contents from the 80s, from the late 80s. And they were finding pieces of plastic in their stomach across various species. So each sort of 4-letter, for anybody who's not a bird nerd, each 4-letter identifier on the bottom is a different species of seabird. And what you see in the picture in the offset are these tiny pieces of plastic, which we would call nurdles right now. And I found that really interesting because, sort of not to spoil everything, but my second chapter looks at plastic ingestion in seabirds and the Aleutians as well. And we found similar items in the stomachs of some of the seabirds we had collected from the same species. So these are parakeet auklets. And what we found were these similar little nurdles. And to me, it was sort of mind blowing that, you know, in the 60s, they're finding these nurdles, and in the 2010s, they're also finding the same thing. So this has been an ongoing problem for quite some time for the seabirds too. Moving into the 70s and 80s, there's more work around marine debris on shorelines. And so folks start doing surveys of beach debris on different islands in the Aleutians. And this includes specific research on Amchitka Island. And what you see here are different pictures of different pieces of debris found during marine debris surveys on Amchitka. And I wanted to point out this little buoy, this little float on the bottom of the slide, because those are things that we're still finding today when we do marine debris cleanups out on St. Paul. So this debris, you know, these types of debris, these types of buoys and floats have been in the ocean for a really long time and end up on our shorelines. There was also a lot of at-sea research around marine debris in this time frame in the 70s and 80s. And folks were doing surveys of the ocean surface for marine debris to track what was out there along different transects. And then they were also looking for what they called back then Newston plastics using a plankton tow. Today we would call it microplastics. And but we didn't have that term back then. Microplastics weren't sort of coined until mid 2000s. But it's just indicative that in the Bering Sea region, folks were doing this type of research, decades ago as well. And then finally, in the 90s to now, one of the big things that we see is work by communities to clean up their shorelines and track and categorize the debris that they're removing from their shorelines. So the data that you see here, just to break it down, the Sitka Sound Science Center helped Bering Sea communities in the from like 2008 to 2018 conduct marine debris cleanups. And what they did for each cleanup, they would categorize and weigh the types of debris that they removed from their shorelines. So in that 10-year time frame, the communities in the Bering Sea managed to remove almost 1.2 million pounds of debris from their shorelines. And you can see the different categories broken down here, but what I want to do is I want to take that space in the purple and sort of put it all together, because all of that represents the type of debris that's related to the fishing industry, whether it be line, net, or buoys or whatnot. So almost half of the debris that was removed was from the fishing industry. And then that big blue chunk that's a little bit over a quarter is other non-vessel gear. And I just wanted to sort of point that out to you, that despite, there being lots and lots of stuff related to fishing industry, there's also a good chunk that is just coming from other sources of through in the ocean. And then here's a map of the different communities that make up that big pie chart. And I realized that the little line graph in the lower left corner isn't very large, but I just used that as a way to show over the decade, the weight collected in each year. But I just want to point out, just because in 2009, there was much more debris collected off the shorelines in comparison to the other years, doesn't mean that there was more debris in that year. It just meant that collectively, there was probably more effort to remove debris. There was probably more money to do the work, and logistics were easy enough to get it done. 1.2 million pounds of marine debris doesn't even scratch the surface of what's out there, but it is indicative of the very hard work that communities do to keep their shorelines clean. The other thing that pops up in terms of research sort of more currently is that folks were starting to realize that plastics are not just physically polluting the environment. Plastics are able to absorb chemicals. They're also, when they're manufactured, they're covered in chemicals, right? So they already sort of put certain chemicals into the environment when they get there, but they also act like sponges and absorb other chemicals, which means that it's transporting not just the physical plastic, but other types of contaminants as it moves through the ocean. And this is really important for things like persistent organic pollutants that live in the ocean and get transported around, because those are, carcinogenic and harmful if they are ingested by animals or humans or whatnot. And then in my next chapter, I'll talk a bit about phthalates. Those are also really harmful in different ways. And so that was a really interesting thing to learn and sort of dive more deeply into, because we think about marine debris as just this, this object on the shoreline or something that people can, that animals can ingest or get entangled in, but there's a whole other level of contaminants associated with that plastic as well. So sort of wrapping this all up, what did we find out? Well, one of the big things is sort of realizing the sources of marine debris in the Bering Sea. Fishing gear is a major contributor to marine debris in the Bering Sea, but we can't really disregard the major contribution of non-fishing debris. It's sort of a little bit of everything. And what do we identify our knowledge gaps as? There are quite a few, but just for the purposes of here, we figured out that we really need to better understand the distribution of microplastics in the Bering Sea ecosystem, because we saw that one paper of the Newston Plastics doing a survey of debris across the ocean, but that hasn't really been updated. And, decades later, we're probably going to find something different than what had been originally found. Also talking about those, that distribution of plastic-associated contaminants, like I just said. And then community perspectives on this issue. It's one thing for communities to go out there and conduct marine debris cleanups, but that doesn't really capture their concern or their observations over time. And so sort of capturing that piece of information is really important too, because it can help drive management decisions or, broader choices to be made to help clean the environment. And then finally, this is sort of an overarching issue for marine debris research, and not just marine debris research in the Bering Sea. We need to better understand the long-term ecological impacts of marine debris on ecosystems. We know that, an entangled seal gets harmed because it has, either a packing band or a net around its neck. But does entanglement overall have an impact on the population? Does it decrease productivity? Does it impair physiological parameters? Same goes for ingestion of plastic and so on. So for the next two sections, we're going to concentrate on just two of these issues. First, the distribution of plastic-associated contaminants, and then looking at community perspectives on the issue. So this is some of the research that I conducted throughout my graduate years. So on to the next question. Are wildlife in the Bering Sea exposed to plastic-associated contaminants? And that brings us to chapter 2, plastic-derived contaminants in Aleutian archipelago seabirds with varied foraging strategies. Although I did cheat with that picture because that puffin actually lives on St. Matthew, but I thought it was too cute and I could not use it. So the part of the Bering Sea that we're heading to this time is the Aleutian Islands, which is part of the Alaska Maritime National Wildlife Refuge, who assisted in getting this research done. And when we're talking about plastic-associated contaminants, there are various chemicals that plastics are coated in or that plastics can absorb. The ones we're going to concentrate on here are called phthalates. There are many kinds of phthalates that are manufactured. We are going to focus on these 6 right here. And they're used for various items that we sort of use in our everyday lives. Something like DEHP often coats medical gear, medical equipment, and tubing and things like that. It is associated with personal care products, nail polish, Some things are even found as insect repellents. So phthalates are chemicals that are found everywhere. The other thing about phthalates is that they coat the surface of plastic. They don't actually get incorporated into the plastic itself, which means that if it's sitting on the surface, it can actually leach off pretty easily, meaning that it can sort of separate from the plastic. It can become aerosolized. If you touch things that have phthalates on them, sometimes it can be transferred to your fingers. They have been found in all components of the environment, from the water, the air, to soil and whatnot. So they're pretty ubiquitous. And I'll get into why that's a problem in a bit. So the objectives of this section of research were to quantify phthalate concentrations in muscle tissue of seabirds from the Aleutian Islands, and test for differences in phthalate concentrations among birds from different geographic locations and feeding guilds. And I just want to sort of stop here for a second and sort of answer the question of why seabirds. A, seabirds are awesome. B, they are a really important component of the ecosystem in the Aleutian Islands and sort of the Bering Sea region in general. The Alaska Maritime National Wildlife Refuge harbors the largest proportion of breeding seabirds in North America. They are sort of critical to all parts of the food web, and they're also considered environmental sentinels. So what that means is that when they're a canary in the coal mine, essentially, their health and their success as a population reflects the health of the ocean overall. And so when we study seabirds and what's happening to their populations, we get a better sense of what's happening to the ocean ecosystem in a bigger picture. For anybody who's been in Alaska a long time, you might recall back in 2016, we had a major seabird die-off, and that helped us clue into the idea that, this large blob of warm water was moving around in the Northern Pacific and Bering Sea, and it was having a really huge impact on the ecosystems as it moved. And that die-off really is what signaled it to us. Okay, so back to the methods and what we did. So in order to quantify phthalate concentrations, we first had to do seabird necropsies and remove muscle tissue samples from our seabirds and analyze that tissue for phthalate concentrations using LC-MS, which is liquid chromatography mass spectrometry, which is a mouthful. And we definitely, as we were doing these chemical analyses, we wanted to make sure that quality control was a big component of this, because we were looking at chemicals that are plastic associated, and plastic is everywhere. So the risk of contamination was really high. And so this work was really important. The important part of this work was to maintain good quality control to make sure that our samples were actually, or our data were reliable. So we analyzed 115 samples overall. And just to break this down really fast, we had 4 different categories of feeding guilds. So like the type of food that the bird was eating. And then they came from 3 specific island regions. And I'll break this down in the next couple slides. So when it came to island regions, we broke it into this Western, Central, and Eastern bit. And we wanted to use this idea of, is there a geographic variation in the distribution of phthalates in the Aleutian Islands? We also wanted to see if the types of food that the birds were eating were impacting the phthalate concentrations. So we had a group of diving fish feeders that we looked at: our pigeon guillemot, tufted puffin, red-faced cormorant, common murre, pelagic cormorant, and horned puffin. Really cute birds, all wonderful. We had our surface fish feeders, so our black-legged kittiwake and our northern fulmar. And then we had our plankton, our diving plankton feeder, the crested auklet, which, if anybody's ever been around crested auklets, they smell like oranges and they're adorable. I love them very dearly. And then our opportunistic feeder, which was the glaucus wingull, meaning that that bird will eat whatever is in front of it. And so what did we find? Well, overarching result was that every bird that we tested had some level of at least one of those phthalate chemicals in its muscle tissue. So across the board, every bird was exposed to at least one kind of phthalate. We didn't really find any variation by geography. There was no significant difference when we tested the averages across those regions. And we did find that there were certain phthalate types, so the DEHP and the DBP, that sort of popped up more often in comparison to the other 4 phthalate types that were found in the muscle tissue. However, when we looked at the phthalates by feeding guild, we did happen to find a difference. And I figured I would take a moment here to break down these graphs because this is the one where we see the difference among the phthalate concentrations. So on the horizontal axis, you see 4 groups. These are the different feeding guilds. And inside the box will tell you how many samples make up that particular group. And the box is showing you the mean or the average. The big sort of line coming up is our standard deviation. On the vertical axis is the mean total phthalates in nanograms per gram, which is equivalent to parts per billion. And what we did was, so each individual bird had its muscle tissue analyzed. It came back with 6 numbers, a concentration for each type of phthalate. And what we did was we added that all up to get our sum of phthalates for that individual. And then we calculated the mean value across the groups and did a statistical comparison to see if there were any differences. And so in this case, the crested auklet, the diving plankton feeder, had significantly higher phthalate concentrations in its muscle tissues in comparison to the other birds. There could be multiple reasons for this happening, but what we would suggest is that possibly because it's targeting plankton or small pieces of food, it could be mistaking things like microplastics for plankton. So it could be that these birds are eating plastic more directly in comparison to the other birds that we looked at, and so have a higher risk of getting exposed to phthalates because of that particular behavior. And, when you think about it, birds don't know what plastic is, right? So they're eating things that they think are food, but no one's telling them that's not food. And then the same thing happened where, where DHP and DBP were also found in high concentrations in these, when we sort of put these samples across by feeding group, but also in our opportunistic feeder, in our gull, we had high levels of DMP. So kind of returning to our research priorities, were we able to sort of get a better idea of the distribution of plastic-associated contaminants in the Bering Sea? I would say we got a little bit closer. We might not have found a geographic variation in phthalates across the Aleutians. I mean, we could just say that they're distributed across the Aleutians in general, but we did figure out that, when we're looking at this by species, diving plankton feeders could be at higher risk of exposure in comparison to other species in the Aleutian Islands. And that's what I said. And DHP and DBP were the most prevalent types of phthalates that we found. And that could be related to the fact that they're actually some of the most common phthalates that are used for different products. Like I said earlier, DHP is often associated with medical equipment, and there are lots of hospitals using lots of medical equipment. So it's a pretty widely used type of phthalate in comparison to the others. For future research, because honestly, this sort of work always begs more questions than it answers, we really want to understand better the route of phthalate exposure, whether these birds are getting exposed through just direct plastic ingestion, biomagnification through the food web, exposure through air or through water, but then really wanting to understand the long-term impacts of phthalate exposure on seabird populations. And this is where I'm going to sort of circle back to the idea of why do we care about phthalates in the environment in the first place. Phthalates are chemicals that are known endocrine disruptors. In other words, that they mimic hormones when they get into the bodies of living organisms. And so we are capable of metabolizing things like phthalates rather quickly in our body, but it's sending the wrong signals. And so it could have really negative impacts on reproductive health, on behavioral health and development. And we don't really know the long-term impacts for seabirds when it comes to exposure of these endocrine disrupting compounds, but it would be important to find that out. And so studies in the future that could help us better understand that will be really great for knowing sort of the long-term impacts of phthalates for these birds. And I'll just add that there is ongoing medical research for humans when it comes to phthalate exposure, but it's not pretty, so I won't dive too deeply into that. Okay, so almost to the end, I'm going to do a quick intermission because this is where we leap from chemicals and seabirds to people on St. Paul. And the reason that I got to St. Paul was because of doing a lot of education and outreach activities around seabirds and plastics and sharing what I was finding out with everybody. And I fell in love with St. Paul and was offered a job there and got to and continue to be part of, the team that gets to work on ecosystem research out there. So always super grateful for that. And when I got out there, one of the first things I got to do was work on a marine debris cleanup. And it was astounding how much debris was on this island. And really coming to understand that a lot of it's coming from other places, but a community of about 400 people are working really hard to remove tens of thousands of pounds of debris. And that didn't seem very fair to me. So it drove me to sort of create this last part of the research where I wanted to really better understand how coastal communities experience this issue of marine debris and what we can do about it in the long term. So that brings us to chapter 3, including coastal community voices in the marine debris conversation, perspectives from St. Paul. And that's where St. Paul is. I also included St. George in the little loop, only because we've also been doing work with St. George to tackle the marine debris issue over there too. Again, this was all done with the help of tribal government. And so I just want to give them a shout out. And the objectives of this research were to examine trends in type, relative abundance, and distribution of marine debris based on St. Paul Island residents' observations, and understand community members' perceptions of marine debris origins and its impact on the local environment, so that we could catalyze the inclusion of local knowledge in marine debris solutions for St. Paul and other coastal communities. So just a better look at St. Paul. It is smack dab in the middle of the Bering Sea. It is a community of about 400 people, and it's awesome. If you've ever had a chance to visit, you're very lucky to get to see a very special place. And if you ever do get a chance to visit, I highly recommend it. One thing that I have learned over time working for St. Paul is, different values that drive the community. There's a really important sense of environmental stewardship amongst community members. And one of the Untitled values that I feel like really shaped the work that we do through Ecosystem Conservation Office is this one. Life is gifted to you. What you make of it is your gift in return. And I hope that, as we sort of continue to tackle this marine debris issue, we continue to embody this particular Untitled value. So the way we did this work was we conducted semi-structured interviews with community members. Participants were 18 years and older and have lived and or worked on St. Paul. And we used a combination of open and closed-ended questions. Our closed-ended questions gave us our quantitative data. So we used a Likert scale to do that. And I'm just giving you an example of what our Likert scale looked like. We asked folks to sort of reach back into their memory and figure out what the relative amounts of debris, of particular types of debris were in specific time periods. So, the first line gives you an example of buoys. So the relative amount of buoys in the 70s was low for this example, and so on and so forth. Our qualitative data and our open-ended questions included questions like, how would you define marine debris? What kinds of materials are marine debris made of? Where do you think the marine debris comes from? Do you think plastic affects the environment? Oops. Do you think plastic, sorry, yeah, there we go. And what we did with our qualitative data was we used thematic network analysis to analyze the answers from these interviews. And so, for example, we did this in the sense of like, we wanted to ask folks about the definitions and descriptions of marine debris. And so we had our different answers that we broke down into basic themes. And so our basic themes included people answering about material type, answering specific objects, or giving definitions of what marine debris was, whether it's trash or something that doesn't belong in the environment. And from there, we sort of grouped these basic themes into organizing themes. So the first two became descriptions of marine debris, and the second two became definitions of marine debris. And then finally, we took that and created a global theme from our organizing themes. So those become marine debris is diverse and prevalent on St. Paul Island. And so from the interviews that we did, we created, or we sort of found 4 global themes, and that's what I'm going to review with you now in our results. We conducted these interviews from 2017 to 2021. There were 30 interviews with 36 participants. 2 big things were prevalent throughout the answers, lots of references to plastic and lots of references to fishing gear. So I just wanted to make sure that throughout all of this, these are sort of the underlying themes for what we found in our interviews. So for our quantitative data, that Likert scale that I showed you earlier, one of the big things that we found in terms of trends is right here in this corner. When we asked folks about plastic bottles and their observations of plastic bottles over time, that's the one that really saw an increasing trend over time. And you can actually see this sort of jump from the 70s to the 80s, which some folks indicated was when they sort of switched over from glass bottles to plastic bottles. And you could see it sort of gradually increase after that. So to our global themes, the first one, like we said, was that marine debris is diverse and prevalent on St. Paul Island. Examples that were given included things like fishing gear, bottles, packaging, boxes, containers, and packing bans. And for a few folks on the call, you know that packing bans are a particular focus of mine for other projects. And then wrappers. So our second global theme was that marine debris quantity has been stable or increased since the 60s with variation among specific types of debris. And as an example, one of the quotes from one of our interviews included this idea about the changes in plastic. So plastic containers, plastic bottles, plastic oil barrels, buckets, the trend started going towards plastic in the 80s for sure, 90s and all the way up. So that is really something that was prevalent throughout our interviews, was this shift towards more plastic on the shoreline. The third global theme was that marine debris does not originate on St. Paul Island. And I think that this is really important to discuss because, you know, I've participated in marine debris cleanups on St. Paul. We've collected like upwards of 20,000 pounds from just a fraction of the shoreline. 400 people can't create 20,000 pounds of debris. And so it is evidence that much of it is coming from other places, including a lot of the fishing gear. The local fishing fleet is actually a halibut fleet. And much of the gear we're finding is related to trawl fishery and big nets like that that are not based on St. Paul itself. And another quote is sort of evidence of that. It's pretty obvious, fishing vessels, vessels in general, that would be the number one. When I say marine debris on the beaches today or trash or items on the beach, I almost look at all of it as marine debris, not so much as island trash. And while there's some litter on island, it's not what's making up the major component of the marine debris we're collecting from the shoreline. Finally, St. Paul Island community members are concerned about the impacts of marine debris. And this was a really big part of folks' conversations with me. And some of it, you know, was really evident of concern for the animals that also call St. Paul home. And not because those are animals on which community might subsist. It's for the life of the animals and the health of the animals and the health of the ecosystem itself. That was a really big concern. There was also concern around, you know, having healthy food to access related to contaminants and whatnot. But it was really this overarching empathy for animals not having to be exposed to this pollution. And just concern overall for the future. So another quote that came from these interviews said, "We shouldn't even be having to do this. No, it's not cool that I'm going out with a group of kids and we're picking up garbage. We should be out here gathering good things and eating good things and enjoying life. And so it was really evident as I talked to folks that concern for the future is a big part of why they want to see this marine debris issue tackled. And so, one solution is marine debris cleanups, but they're not necessarily enough to solve the problem. You can't continue cleaning up all the time. So one person said, it's like a cat chasing its tail. They go out, they make a beach pristine, and we go out there a year or two later and bam, tons and tons of garbage again. I think to be impactful, we would even have to get to the source of the problem. And that was a message that came through loud and clear. Getting to the source of the marine debris is really important, and preventing it at its source is going to be the thing that makes this issue less of an issue in the future. So I think through this, we were able to capture some of the community perspectives on the marine debris issue from St. Paul as a case study. And some of the things that we sort of concluded after doing this work was that marine debris, it's an environmental justice issue for coastal communities, particularly those in Alaska. And it's complex and requires multi-scale solutions if we really want to tackle it. But if we're going to find solutions, we need to include community voices. And I said specifically here, marine debris action plans. And I would like to just sort of state that we are working on an action plan for Alaska, and AWA is part of that. We have meetings once a month to sort of figure out how we're going to make that happen for Alaska. It's such a complex issue in this state that we haven't been able to really come up with a super comprehensive action plan, but we're getting there. We're working towards it. Okay, so to wrap this up, solutions have to happen at multiple scales. I did this presentation with prior to the UN meeting to actually talk about having a global plastics treaty, and they met last week and sort of are pushing through a global plastics treaty, which I think is awesome. I don't have all the details about it at the moment. I haven't had a chance to catch up on it, but I think it's a good first step to sort of have something on the international scale to tackle the plastic issue. On the national level, we have the Save Our Seas Act, which also specifically mentions marine debris prevention and sort of finding plastic alternatives and marine debris cleanup. Like I said, on the state level, we're working on an action plan, which is going to be led by the NOAA Marine Debris Program, but it's going to include as many stakeholders as needed to make sure it's comprehensive. And then on the local level, different communities are doing the work to clean up debris and find ways to prevent debris entering the environment as well. Not just St. Paul Island, but lots of different communities across Alaska. And then folks are working towards this concept of a circular economy, which is something in the sense of, really improving this idea around recycling and not creating new plastics, making sure that the plastic that's already been made gets reused again and again. So I'm hoping that that idea of a circular economy catches on and we can prevent so much waste creation in the future. And I'll end it with the idea that it's not all terrible. There are lots of people doing lots of good things around the marine debris issue, not just in Alaska, but across the globe. I included all the pictures here of all the kids that I work with on St. Paul because they give me hope for the future. But, as overwhelming as something like marine debris can be, sort of, for me personally, it's kind of on the level of climate change. I also would argue that climate change and marine debris are sort of intertwined in a lot of ways. It's good to know that there are people working hard to tackle this issue. And so with that, because this was my defense presentation, I'll thank my advisors and my committee and all the folks that have helped me get across the finish line, but also AWA for inviting me here. So I will stop it there and open it up for questions. I know I'm hitting like real close to time, but hopefully if folks want to stay, I'm game to stay.
Thank you, Veronica. I acknowledge that we're at just on the cusp of 8 o'clock, and if people have to jump off, that's fine, and same with you as well. But if you're able to stick around, then we can continue on with some questions, and otherwise you can throw your contact information into the chat and people can reach out with questions as well.
Yep, I will put my email in the chat right now.
Okay, great.
Um,
Well, I want to be the first to say that, holy smokes, there's so much information in there that is just, it's very clear that you've put in a ton of work and a ton of time into everything that you just shared with us. So thank you for everything, for relaying all that, and also for all the work that you've done. So really wonderful work. And we do have a couple of questions already started off. Someone asks, for the quality control of contaminant analysis, they believe it was chapter 2, ? Were you following some sort of EPA quality assurance criteria?
so there are no specific quality assurance criteria from EPA that we were using. So I worked with the Asset Lab out of UAA, and basically across the board, and this is sort of one of the issues with phthalates, is that people are trying to figure out like the best way to measure phthalates. We were sort of using internal quality assurance controls. So the folks that I worked with, Dr. Kenish and Dr. Hagedorn, had sort of perfected their process to so for example, a lot of other labs are able to measure phthalates in parts per million, but not in as fine a scale as parts per billion like we were able to. Their quality assurances were really super high, ran lots of blanks, ran lots of controls, had like a whole set of tissues that they had run again and again and again as their control samples that were separate from mine. So we knew when like we were running blanks or when, you know, there was drift in the data. So that's kind of where our highest quality assurance was, but also on the end of sample prep, making sure that nothing touched plastic. We used sort of all metal and aluminum foil. And that was sort of our big piece on our end to ensure that we were not contaminating our samples. Hopefully that makes, is that good, Doug? Did that cover it? Yeah, thumbs up. Excellent. And you also had another question about the collected debris. Great question, because this is one of our biggest barriers and it's so frustrating. So we store our categorized debris in super sacks, like these big, you know, those big white sacks that they use on ships. And the intention is to barge them off to various locations. So we have been trying to do a follow-up cleanup since 2019, but COVID has prevented us from doing it. And for the funding for our newest marine debris cleanup, we actually partnered with a group called Net Your Problem. And they were going to take our nets at least and get them recycled. Our other debris, we were going to send to a landfill in Seattle, which is sort of the easiest thing for us. But I've been working with a group called the Ocean Plastics Recovery Project in hopes that we could find a different place for that debris to live, to potentially get recycled. They're working on finding various mechanisms to recycle various marine debris items. That is sort of one of the most frustrating parts about this, is getting it off island. It's really hard. And then you think about sort of like the carbon footprint of moving it off island and putting it on a barge and all the gas it takes to move it somewhere else. It's just, sometimes it feels like there's no winning, but we're doing the best that we can.
Yeah,
but
that's a good way to put it.
It's a point of frustration for sure.
Yeah.
And then I saw Linda had a question too.
Yeah.
Sorry. I'm like scrolling through myself.
Oh no, I'm glad you're catching on to them. There's tons of kudos as well. Yeah, wondering about the specific function of phthalates and could they be phased out?
Thank you, Linda, because I meant to say that. So phthalates have different functions depending on which one you're using. Some impart flexibility to, so plastic, you know, when you make the polymer, it's just sort of like this virgin plastic, which can sort of often be brittle and inflexible. So phthalates, when you coat them, can add flexibility to a polymer. In some cases, it adds clarity. One of the phthalates, I want to say it's DBP, but they sort of like have been using so many different phthalates these days that I'm not sure if it still counts, actually makes things waterproof. So like when you watch the water run off your rain jacket, sometimes those are phthalates at play. So they can do a lot of different things. There are a lot of phthalates used in PVC piping to make it like more durable. But those are some, and then the other one that, you know, sent me into a tailspin when I first started finding out about this stuff and made me start buying like the fancy like face wash. They act as an emulsifier in soaps. So they give soap that gelatinous quality. So I started buying everything that said phthalate free because I was like, I don't need that on my skin. But yeah, it's everywhere.
Yeah, it gets spooky when you think about it. Yeah. Wow. Thank you. That was a very great answer. And scary. Doug asks again, the plastic is so degraded. Is it realistic to expect to recycle any of it?
Yeah, that's a great question. And it hadn't been for a long time, but these folks at OPR, at Ocean Plastics Recovery, Scott and Andy, they're working with folks with Hewlett Packard and universities that can sort of find ways to break down the material to a degree. Like, you know, some folks are trying to turn like plastics back into fuel because, you know, another thing I didn't mention, but most plastics are petroleum-based products, right? So they're trying to find mechanisms and chemical reactions that will break it all the way down that way, and utilize it on that end. So while some things are super, super degraded and right now seem like they're not usable or can't be, you know, given a second life, there are scientists out there working on getting around that hurdle. So it doesn't exist now, but it could exist in the future. I'm going to hold out hope for that one.
That would be incredible. I don't think I'd heard of that before. Man, the demand for marine debris would just skyrocket.
Well, you know, it's crazy because like there are actually a lot of people who are turning like recycling this sort of stuff into a business because they're finding the good methods, but like we're not good at recycling overall. We're terrible at recycling actually. Like I think the last stat I saw was that we only recycle about 9% of plastic in the US. And what we called recycling for a long time was just us selling it off to China. But China put in their sword policy and they were no longer accepting our recycling items. So we have a bigger waste problem these days than we did even, I think the sword policy went into effect in 2018. So, you know, even 4 years ago.
Well, I have one last question to end on, and I know you mentioned it at the end of your presentation. How do you keep the faith and just stay hopeful? And it is, like you said, it kind of feels, I know it's intertwined with climate change, but it feels daunting like climate change from time to time. And if that's your day to day, it would start to probably get pretty heavy, or you would just get numb to it either way. But how do you do with that?
So I've been doing this since 2009, so you know, over a decade. And I will say that in the last 5 years or so, I have seen more people be concerned over this issue than ever. There are, you know, like one of my old roommates who he worked on northern fur seals for his master's, but now he's doing plastics in whales for his PhD. And more folks are sort of getting into the space of doing the research around the impacts of plastics and marine debris on ecosystems. And so I think we're getting more towards an answer, or not an answer, but like sort of a clarification of what these long-term impacts look like, because I think once we get to a better understanding of that, it might force us into a space to make those harder choices. Center for Alaska Coastal Studies has done a great job of getting a bunch of schools to not necessarily to zero waste, but to reduce the use of like plastic utensils in their schools. I'll also give a shout out to Ocean Guardians, which the Ocean Guardians school program, which they've done some cool stuff in Juneau and have had their schools really like reduce the amount of waste created. I see a lot of, you know, a lot of kids learning about the value of making these choices to protect the environment. And I think that's the part that gives me a lot of hope.
The youths.
The youths, yes. They will save us all.
That's great. Well, thank you. I think that's a beautiful note to end on. Thank you so much again for being here, and for everyone for being here, and really learned a lot. I just am blown away. I'm going to have a lot to think about and digest. So thank you very, very much, Veronica. And again, everyone, this was Veronica's just free time. She was here out of the goodness of her heart. So we are appreciative for her to be here. And this recording will be posted to our Facebook page and our website, and also our YouTube channel. So if you want to share it around, you can do that by end of the day tomorrow and Friday. And yeah, just happy to have you all here. Thank you so much, and hope everyone has a wonderful evening.
Thanks so much.
Yeah, thank you so much.
Have a good night.
You as well. Bye.
Bye.